You all should have the CivilFEM 2016 student version, and this window will appear the first time you open the software. How to start with CivilFEM? We go to this top left corner and click here on the CivilFEM button and open a new analysis. By default, 3D static and structural analysis will be highlighted, but as you can see, we have another options for two dimensions, and if we want to perform a dynamic analysis, we have another types for this analysis, which are transient analysis, modal, harmonic, and if we want to perform a backlink analysis, we can click on it as well. But we will start with a 3D static structural analysis. Once we open a new analysis, we will see this graphical user interface. The first time you will have to activate some windows. As you can see, CivilFEM has Microsoft similar environment as Microsoft Office, so we all have divided everything into tabs, and each tab in different groups. From left to right, we go first to the View tab, and in the Windows group, we activate our main windows. Later or in the next courses, we will see all the capabilities of all the windows. But now we will start with the entities model. Everything that will be defined in CivilFEM will be shown here. Our coordinate systems, geometry, materials, sections. But we need to activate as well another window, important window, which is everything that's shown here in the entities has its own properties. So to see the properties, we must activate the properties window. It's by default here shown on the left. Another window, very important, is the output. Everything, all the messages or warnings and messages from the software, from the analysis, will be shown here. Errors or warnings and all the definition of materials, everything will be shown here in the output. The structure of these windows. Here the main window is the ribbon bar. This is the one in the top. Then we have the entities, as I told you, output and properties. But everything can be. There are dockable windows, so they can be moved, resized, and placed anywhere. They can be hide, clicking on the pin button. And well, in this case, we always we use this structure, but you can use any configuration of the windows. Another important toolbar, but is always activated, is the heads-up display toolbar, which is very useful. And the advantages will be shown later, as long as we will define the geometry and meshing. This toolbar is new for this 2016 version. So as I told you, this is the CivilFEM is divided into tabs. The first one is the environment. In environment, we have the coordinate systems. We can define by default the global Cartesian is automatically defined and cannot be deleted. But we can define another Cartesian, cylindrical, or spherical coordinate systems, which will be very useful to define your geometry or element mesh orientation for loading, etc. The next group are the codes and standards. If we want to, after performing a structural analysis, we can perform code or checking or code design following this standard, these code specifications. and we have a complete list for reinforced concrete and structural steel. The next group are the units, which are very important. You must know that in CivilFEM you can change units anytime, and they don't need to be consistent. So you can use any units for any entity and can be different. You can mix, by default, you can use the international system units. For principal units, you have these newtons meters, and derived units are the ones derived from them, accelerations, masses, pressure, moments, and you have another system units, which are the ones using the feet and inches. But you can use your own user units, and you can always mix from one system and another. And as I told you, you can always mix here anytime for each entity the different units. You will see this in the following examples, how we can deal with different system of units. We can set it by default with the international system. Well, the next groups will be shown. The next, well, the most important are the ones I showed you. The next tab is the geometry. So here we can define our geometry using, we can set the grid here, and we can define all these type of entities for geometry: points, cubes, surfaces, volumes. And once we have defined our model, geometric model, we can perform some other operations as extruding, revolving, Boolean. We'll see with examples how to work with these all these utilities. But as you can see, you have a complete list of different geometry definition. If we want to use an external cut, we can as well import always another model, import geometry from IGS file, step file, DXF, Parasolid. So we have another options of the geometry definition. Then after creating our model, we can we must define our materials. We have a complete list of materials here for steel, concrete. For example, we have the different code and standards. Depending on our standard, we have another complete list. And once we define our material, we have automatically defined all its proper mechanical properties and the code properties. In this case, we have by default the codes, which are the ones selected in the code standards group. But as well, we have another data which are shown here in the properties, in the code properties. And by default, always the material will be linear, but we can change our constitutive law anytime. Okay, in case we want to change our strain and stress behavior, or strain stress curve. So we have our materials for concrete, reinforcing steel, processing steel, and for geotechnics we have a complete list of rocks and soils. But as well, if we want to define a generic material, we can do it as well. The same procedure is for the cross sections. We can define a cross section following our complete library for steel and for concrete. In case we have some particular sections, we can, for the case of steel, we can define steel by plates. Or if we have a different section which cannot cannot fit to any of the ones predefined here in CivilFEM, we can define it just by creating our geometry and our 2D mesh and capture this section to use it later to mesh beam elements. And of course, we have as well cable sections or generic sections where we just set these properties, areas and inertias. The next thing, once we have our geometric model and materials or section, if we need section for, and if we have beam elements, the next thing is to go to the finite element model. So we will have our group of nodes and elements. In CivilFEM, we have these important entities, which are the structural elements. What are the structural elements? The structural elements are each structural element will be a kind of group of finite elements with the same structural behavior. For example, for instance, we have beam structural elements. These beam structural elements will fit for that kind of elements or behavior where one dimension is greater than the other two. For other linear elements, we have thrust and cables. For if we want to consider only axial behavior, and if we want to consider only tension, we have cables as well. For the case when one of the dimensions, in this case the thickness, is is lower than the other two, we can select shell element behavior. And for the other cases where all the three directions can be considered with the same properties, we can choose solid for volumes. Once we have defined our structural elements, how we can deal or how we can perform another options, or how we can change the mesh. In this case, we have another utilities. We call them model utils, which are connections and insertions where we can define couplings or tying equations, or modification of the degrees of freedom between the different structural elements or nodes. We can as well define masses and springs. So we will see in another courses how easy it is to define contact between entities, between bodies. Even if we want to glue two different structural elements, or if we want to define some friction between them, or study some particular slipping or process, or any other analysis where friction is involved. So once we have defined our structural elements, we'll see in our examples how to mesh. After that, we just apply loads. We'll see how to apply loads, how easy it is to apply loads in CivilFEM, defining our load groups, and any type of loads typical in the civil engineering can be defined, and then solve. And the last and after having our results, we just load them and see if everything is okay or not.